Good morning. On behalf of the National Center for the Performing Arts, Mumbai, a very, very warm welcome to all of you. Thank you very much for joining us for this special workshop on the topic of understanding performance spaces from practitioners' point of view. We understand that we have about 300 participants logged in from countries, of course, India, but also UK, USA, Singapore, and Germany. So thank you all for being with us. At the outset, we would like to express our gratitude to HSBC, India, as our esteemed supporters. Their generous support helps us to undertake 5 important initiatives related to the art of music and musicians, including workshops such as this. Today, we present the second workshop of this financial year, as I said, on the topic of understanding performance spaces and insight into architectural acoustics for the performing artist. We are aware, friends, that the acoustic quality of any music for any musical activity is invariably affected by the quality of the surrounding spaces, whether indoor or outdoor. It is therefore important for us as practitioners to understand the actual behavior of sound in any given space. And today, we are very fortunate to have with us Mr. Rolins Roy, who is practicing architect with a specialization in acoustics. He has been an acoustic and design consultant for a wide range of key projects worldwide, comprising studios, private theaters, live music, and performance spaces. His team is involved in disseminating information through technical seminars and lectures such as these to students of architecture and the public works department. And we are also privileged to have him on board for some of our local here NCPA projects. So this workshop is expected to highlight significance of spatial acoustics from a performer's point of view. We will have case scenarios of selected spaces with images from the design stages to completion. Furthermore, it will also focus on other factors that play important role in defining the acoustic design criteria of a performance venue. We take this opportunity to thank Mr. Roy for being with us and sharing his expertise. And friends, the duration is about 60 minutes, after which we will take up your questions. So please post your questions in the link given to you. Over to you, Mr. Roy.
Thank you. A very warm morning to all of you. I'm immensely happy to be on this platform to share my experience on acoustics and construction built spaces. As a student, as a child, I have been growing up seeing the perfectly executed performances at NCPA, and it gives me great pleasure to be in the presence of such stalwarts who have run this institution with such great pride. So I start my presentation now. I'm going to call this an experiential imprint. This is the first few slides I always start with when I have to speak about this subject, mainly because people find the physics of sound very boring or maybe too dry to understand. So that is why my presentation is going to have a lot of images. And fortunately or unfortunately, nothing in this presentation is AI generated, so kindly excuse the human errors. So what are the performance objectives for the desired experience? Okay, so we put it as speech intelligibility, controlled ambient noise, system design, isolation, and to achieve that design criteria, you need to always work on the room size and geometry. And then there is the prime listening position from the perspective of the performer as well as the audience. And then there is the acoustic treatment in tune with the audio video setup. Yeah? Then comes the interior design and appearance, because after all, when you enter a space, what moves you will make you stay calm, and then you begin the performance with that ambience, So all these points are very important to actually have the desired experience. So now moving on, what I've done is I've put some pointers with which I actually plan to conclude the presentation, but I'm putting it in the beginning itself so that these are the very basic points that as a performer you can look into. The 10-second sound check hack. While you walk onto the stage, clap sharply once and listen. At your position, are you hearing a metallic ringing? That's a flutter echo. Okay. So now you have to adjust your stage position or instrument angle slightly to avoid those direct parallel walls or maybe some reflective surfaces from where you're hearing a flutter. Does the sound vanish instantly? Prepare to put more physical energy into your projection or request more on the monitor mix. Okay. So why does this happen? There is something called direct sound and reflected sound. So direct sound travels straight from the instrument voice to the listener. So if you're sitting there, there is something that is directly reaching you, and there are multiple order of reflections around because of an enclosed space. But when it is a free field is when you are in an open arena with no roof, no walls, maybe in a concert on open ground, then this does not apply. Then there is something else that I would like to talk to you about as we move forward. Then there is something called adapting tempo to the room. So now if this room I am hearing a little bit of reverberation, now you will ask what is reverberation? I will talk about reverberation and echo separately, because we always say this room has a bit of an echo. That's probably the wrong term you are using. So what is adapting tempo to the room? So if you find yourself in a highly reverberant space, for now I'll say the layman's term of, okay, you find the space having a lot of echoes, which is not the right word to use, you slow down the performance by 5 to 10%, because you elongate the pauses and crisp up your consonants. Now if for example when I'm talking over here in the space, I hear the room back at me, I have to slow down. I have to make my words more elaborate. Okay. So for example, for singers or actors or staccatos for instrumentalists, to give the room time to clear itself. Okay. So then there is the audience factor. A packed house absorbs significantly more sound than an empty rehearsal room. So performers must anticipate that the room will feel drier. Drier, when I say, is absorbent, very absorbent, and tighter during the actual show compared to the sound check. So during the sound check in the auditorium, you might not have an audience. Okay, you might have just the seats. That's the main reason as designers we add certain absorption to the seats so that it simulates a fairly packed audience in an auditorium. So what is reverberation time? Just a very basic. Sometimes it's called a wet room. Wet room means there is a very long reverberation time in the room. So this is ideal for pipe organs or choral music, but turns rapid articulation like a drum solo or spoken theatre into an unintelligible muddy mess. Okay. So if the space is too reverberant, it's called bright or a wet room. And when the reverberation time is very less, it's great for speech clarity or heavy amplification. So you will see studios are mainly built in a dead format. So it offers no character back into the vocalist or the violinist, leading to a vocal fatigue. So if you play a violin or mridangam or certain string instruments in a very dead room, you will not actually get the timbre or the character of that instrument. So working with variable acoustics, now I'll show you some projects as we move forward. So lot of modern venues have adjustments where you can, like contemporary performance spaces have motorized acoustic banners, heavy drapes that can be deployed to deaden a room for a rock band or retracted to bring the room to life for a string quartet. The room that we are in right now is also designed in a certain manner where it can be added with diffusive surfaces for octets and smaller orchestral setups. At the same time, it is for speech, it's for theatre. Now, fighting the room. When a room is acoustically dead, which means highly absorbent, a performer's instinct is to force more air or strike instruments harder. This leads to vocal nodules or repetitive strain injuries or premature fatigue. Like you have a 3-hour performance, in the beginning itself you start feeling tired because you are pushing yourself too much. This also relates with teachers who are teaching in classrooms. So you will see that most of them will have some kind of heart ailments and all that, because all through their life they have been pushing themselves, especially when it is not an air conditioned room and there is a lot of traffic noise around the school or something like that. So finally I conclude these points by saying, trust the architecture. In a well designed acoustic hall, trust that the building is doing the heavy lifting. Okay, so whisper can carry to the back row if the early reflections are properly aligned. So I've given you these pointers. Keep these pointers in mind as I take you through a journey in the next 60 minutes. So what is sound? Sound waves in gas and liquids propagate longitudinally. In solids, sound waves propagate either longitudinally or transversely. That's why you put your ear to the railway track. You shouldn't do that. I'm just saying an example. So you hear the train coming from far, but at the same time, when your ear is not touching the solid metal rail, you don't get to know as fast as you had it when you heard it through the metal. So as a wave, it can be characterized by its F, which is frequency, lambda, wavelength, T is time, C is speed, A is amplitude. So I wanted to tell you one more thing. If there is more moisture in the air, sound travels faster because there is more dense medium. Okay, so C is equal to lambda by T, which is 344 meters per second if there is 20 degrees centigrade in the air. But at the same time, our temperature is much higher than 35 degrees. So that is why the speed of sound will be much faster. So in physics, sound is a vibration that propagates as a typically audible mechanical wave of pressure and displacement through a medium such as air or water. And by default, we are performing in spaces in which the medium is always air. In physiology and psychology, sound is the perception of such waves and their perception by the brain. So it's not necessary that if I'm finding the sound very comfortable in this environment, it might not be the same with someone else. Yeah. So it's very subjective, person to person. Now the second basic element that I want to express is wavelength, which is in meters, is equal to the speed of sound by the frequency. Now what is frequency? Frequency is the cycles. Okay. So when I'm speaking, I have a certain imprint of my voice. So everybody doesn't sound the same. Like now if I say some so you can mimic an actor by changing your the voice in certain way. That is, you're changing the frequencies of your voice. Okay. So a 20 hertz and a 20 kilohertz both have different wavelengths. The wavelength is the distance that it travels, which is speed of sound by the frequency. Lambda is equal to C by F, you call it. So the speed of sound in air is approximately 344 meters per second. At the same time, if our medium was water, it would have been 1500 meters per second. If we were talking in a space which is the medium is wood, it would have been 3800 meters per second. And if our medium of propagation was steel, it would have been 5050 meters per second. So that is the difference between mediums. Okay. So that is why you hear the train coming from by far if you keep your ear to the rail, which you shouldn't do. So what is frequency? There are pure tones versus complex frequency spectrum. Now when you play a flute, you can hear a more purer tone. Okay. But at the same time, when you're hearing an entire drum roll or an entire drum kit, you're hearing an entire complex frequency spectrum, because each element of the drum kit is giving out a separate frequency element. Okay. So what we have to understand from this is, when there is ambient noise, when there is some other traffic noise, So all this adds to the ambience of a space. So that is the main reason we are so critical about air conditioning and MEP, which is mechanical, electrical, plumbing elements, which define the space. So the second thing, imagine there is no space which is enclosed and you are in an open concert. There is another law which applies, which is called inverse square law. Now what is inverse square law? Every doubling of the distance from the sound source in a free field situation, the sound intensity will diminish by 6 decibels. So you can see the screen, I am projecting something. So imagine that's the stage. With each doubling of the distance, my entire decibel levels are falling. This is the main reason why in open concerts you will find a lot of fills happening at certain distances. That is to reinforce the sound back into the setup. That is why in open concerts you are paying a much higher price for a certain distance if you are buying tickets until a certain distance, and beyond that the ticket price goes down. Now this is the main reason why we have balconies. Now balconies bring you closer to the stage. So that is why concerts in stadiums and all, sometimes the balcony price also is as same as the price of somebody right in front of the stage. That might be because the sound is digitally calibrated to reach you directly than more reflected. Yeah. So all this are part of how we manage sound for a performance space. So as a performer, you have to understand that somebody who is just like within 5 meters of radius, that audience person is going to really enjoy the performance, but at the same time somebody who is like really far away, they are always going to be cribbing with a certain kind of an attitude that okay, I am not able to even see the performer, I am not, but I guess the whole, I mean the audience has also evolved with time, because now the phone is the audience more than the human. So anyways, coming back to the topic, you have to understand that the inverse square law applies when it becomes a free field situation. Now I think this is the final technical element that I am going to explain, and then we will get on to spaces and images. Every space has a noise criteria. Okay, so how much noise should be there within that space, and it is set as per BSE and ISO standards. Okay, so like for example, for an apartment house, the recommended NC, which is the noise criteria curve of that space, should be within 35 decibels. And when you go into conference room, it will be within 25. When you go to performance spaces, it will be within 40. So there are standards set for all these spaces. So if you refer to something like a document BB 93 or many others, Building Regulations 2000 Part E of Schedule 1, you will see all these requirements for art rooms, kitchens, staff rooms, libraries, performance spaces, music classrooms and music rehearsal rooms. Everything has a different value associated with it. So the reverberation time for all these spaces in the mid frequency range differs. Okay. So talking about sound in a room, we have to understand in an enclosed space, sound reflects off the boundaries depending on the reflective and absorptive properties. That is the main reason why most of these spaces will sound different. If it is a rectangular space or a fan shaped auditorium, or sometimes you will see really weird shapes or the geometry is very distinctly standing out from the rest of the spaces. That is because it has been designed for a certain reason for the kind of performances in that space. So you have to understand that a multi-purpose auditorium is not the ideal space where, now of course when you are investing into a space, people want it to behave like a preview theater as well as a orchestral space, as a, I mean it gets used for multiple purposes, but there are limitations. When you design something for reproduced sound or amplified sound, you have to have a more dead space. Dead space means more absorptive space. But at the same time, when you're using natural instruments and you're not wanting to amplify it much, you have to have a more brighter or a wet room. Okay. So reverberation is the persistence of sound, which is reflections in a space, and echo is a discrete and distinctive single reflection. Okay. So that I usually use this when I explain this to students, where when you say hello in a room and you hear a hello, just like a stretched hello, okay, but at the same time when I say hello and I hear back a hello, 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 that is echo, okay. So be very clear what is reverberation and what is an echo, because every enclosed space has certain characters, and a reverberation is perceived when the reflected sound wave reaches your ear in less than 0.1 seconds after the original sound wave. Since the original sound wave is still held in memory, there is no time delay between the perception of the reflected sound wave and the original sound wave. So for example, I am speaking, when I say hello, and the room adds on to the content that I am generating. Since the original sound wave is still held in memory, there is no time delay. So the perception of the reflected and the original sound wave is much different. So the two sound waves tend to combine as one very prolonged sound wave. So if you have ever sung in a shower, and I know that all of you have, then you have probably experienced a reverberation. It's not an echo. The reverb effect sound which you hear is the result of reflection of sounds you create combining with the original sounds. Because the shower walls are typically less than 17 meters away, these reflected sound waves combine with the original sound waves to create a prolonged sound, which is a reverberation. So I have this image which I usually show to students. The reverberation is heard at less than 17 meters and echo is heard at more than 17 meters. Now considering the speed of sound is 340 meters per second. So echo and reverberation, I am hoping each of you have understood this. So now I am not going to use the word echo anymore in my presentation ahead. So this was to keep the understanding of reverberation very clear. Yeah. So now design criteria. When a space is designed only for speech, this is a very old reference. I think J.E. Moore Design for Good Acoustics is probably published back in the 1960s. So he has defined, for speech, a space like a lecture hall or conference hall should have 0.6 to 1.2 seconds reverb time. Okay, this is in T60. Now most of the measurements that we do is T20 and T30, because we have magnified further. We are going further into detail to understand how the room is recreated. Yeah. So speakers, there are trained speakers. Not everybody is a trained speaker, you know. So that is where theaters are designed accordingly, with a little more reflections into the space, so that your voice reaches out to the audience. So those theaters, 1 to 1.4 seconds is the ideal reverberation target. So I've set an entire list over here, which you can see it on the screen. So multi-purpose use, what it should be. But multi-purpose use, now it is not 1 to 1.5 seconds. It has come down to 0.6 to 0.7 seconds, because we have highly reinforced systems being used in auditoriums now. And when it is for solo instruments or choirs, orchestras, the requirement is much higher. Concert halls will have 1.6 to 2.2 seconds. So you understand each requirement has a different signature that we have to design for. Now again, as I said, these things are all standardized by now under the BSEN ISO standards and ASA standards. All across the world, people have set different standards, but all of them almost are similar. Now there is something called speech transmission index. Now speech intelligibility, it's called the STI value. So for example, it is defined, or it is measured through the reverberation time of a space. So when I measure the space, and if the STI value is less than 0.36 seconds, it comes under the band U, which is not suitable for PA systems. So you should not use reinforced systems in such spaces. There are chances that you might have a small concert or a small gig, and you saw a hall and you're like, okay, let's call in 100 people or 50 people here, and let's have a gig here for 2 hours. You might not have tested the space. You will go there, you will set up everything the way you want it, and then you realize, okay, I'm not able to hear myself, you know, and there is a lot of reverberation, not echo, okay, and you have hired heavy systems for the space, and it's only going to worsen your situation, okay. It has to be very clear that your space, or that, so you can see that concert halls and classrooms have a STI range requirement of 0.6 to 0.64. Okay, only if it falls within that bracket will your perception of sound will be comfortable to the audience, and the speech that you are actually expressing will be clearly understood. Okay, so there is something called clarity of music and clarity of speech. So C80 and C50, these are all parameters that we use for defining a certain space. So be very careful, see to it that you do a sight recce before you enter into any space or enter into a contract with any event management team. Most of them goof up during the space selection time. It might look great, it might have really fancy plush interiors, and suddenly you reach there and you can't hear yourself. So you have to realize how should that memory of your concert be. So be very careful, do a sight recce before you set up the requirement of sound and video as well. Okay. Now I'll start with certain examples. Now these are real case scenarios. I will be showing some projects. A lot of projects I am not actually supposed to be revealing too much information, but I will just show you certain information which will be easy for you to understand the concept of acoustics in architecture. Yeah. So this is a huge dome that I am showing you, which is more than 20 meters. Now you will see I am putting 50,000 rays into this space. Okay, and you will see how the waves behave. There is something called first reflection. Now I have shown you an entire graph there, order. That order denotes, 0 denotes direct sound reaching you. Then there is green, which is 1, which says the first order of reflection. Imagine it has just hit one surface and come back to you. Then there is 2, which is the second order. Again, it might have hit 2 surfaces and come back to you. So in this image that I am showing you, the red dots are the sources, and 0, 1, which you see, is the receiver. So what that receiver is going to hear is what is being graphically shown in the space. So now you will see that red part is the direct sound. The blue, green, yellow are the first, second and third order of reflections reaching you, and you can see how it still stays around. Those red bands on the walls are something that we are trying treatments on the wall just to understand how will it improve in that space. So in this space, then we generate graphs like this. So we simulate, we measure, it's called a pre-treatment measurement, and then we do something called a simulation prediction. So with the right inputs, we can actually arrive at almost accurate oralization. Oralization means even before anything is built, or even before you do a gig in a certain space, you can actually oralize it. You can put some track of yours into a specific software, and here in that space you can actually sit on one of the seats virtually and understand if this space will sound right for my performance or not. Yeah, this is a very interesting direction that most of us have been using now, and it makes it much easier, much faster, without any guesswork, to arrive at the right situation. So you will see blue line indicates the existing scenario estimated through the measurements at site. Now when the Sim 1, Sim 2, Sim 3 are the simulations of different treatments done within that space, and how the reverberation time drops down, and then what is the ideal in that existing limitation, that also I have shown in this graph. Then while showing that graph, these are the actual values. If you see on the left, that is 63 Hertz to 8000 Hertz, and then I am showing you the STIPA, which is the speech transmission index for PA systems for each of those case scenarios. So you will see it is much less than the required, which is 0.6 seconds. So I am getting only 0.48. So whatever I do, even if I bring in reinforced systems, I will never be able to achieve clarity in that space. So this gives you clarity on, should I really invest in that space to treat that space? Even after treating, it is not reaching the required value. So you rather save your money and put it into something else, rather than trying to undertreat something, which is not going to be useful for future. So these are ways how we manage spaces, the enclosed ones. So we have a certain kind of a graph which we try and understand, okay, the scenario 1 is not suitable for PA system. So scenario 2 with proposed acoustic treatment, it's still not reaching there. So you take your decisions accordingly. This helps align our conclusions for spaces or for performances, what kind of performance. So maybe you want to do a meditational gathering there where you are chanting certain songs or certain things which have a long a legato mode. Okay, so then it makes sense. It will give you a meditational element into that space, but at the same time, if you start having percussion and those kind of elements in that space, it will not be helpful. So a space like that could be treated like this, where I'm showing you a very plush interior with treatment. So it's very important that the interiors of a space match along with the technical abilities of that space. Most of the time we have certain vision in mind, we do it that way, but it is not technically fulfilling the requirement. Okay, so I'm sure you would have seen all these materials that I'm showing up on screen. Everything has a different absorption coefficient, diffusion coefficient, scattering coefficient. There are multiple parameters for each material. So don't make the mistake of adding any one thing and just, okay, let's go to this room, I want to create a studio, I'll just put mineral wool all across the place. It will dampen some frequency band of the audio being heard in that space. You have to make sure that the three important trios, which is absorption, diffusion, reflection, is equally managed in that space through the material usage and the geometry. So now let's go back to the Baroque times or certain cathedrals or certain really old temple palaces and many other places where you really enjoy a traditional art form. Why did you enjoy it? Of course, the interiors matched with the acoustics of the space, which you cannot see. So acoustics is that subject where you only experience it, and then irrespective of how plush that space is, it will define your experience or the memory of that space. So that is why you will see a harpsichord or maybe a piano or maybe a sitar or surbahar. When it is played in the right space, or maybe in most of these instruments have the geometry or the the way it's made, it was to push the sound out of that instrument into the space. So the space has to complement the instrument. Okay, so you will see in example, Baroque music was performed in the halls of mansions which had balanced acoustic signature due to the extensive use of wood paneling in their decoration. So this paneling acted as an effective low frequency absorber, and in conjunction with the flags, drapes, tapestries which also decorated these spaces, provided the necessary acoustic absorption. So in many cases, much of the required absorption can be achieved by using materials which fit naturally in the room. Okay, so I am showing you this nice graphical interface which I saw on the engineering toolbox. The plywood, concrete block, glass, brick, tile, all of this have different sound absorption coefficients along the frequency band. The X axis that you're seeing is the frequency that it denotes. So a combination of absorber designs would give the best performance across a broad range of frequencies, okay, which is called broadband absorption. So things to remember: one is noise reduction coefficient and STC, which is sound transmission class. Noise reduction coefficient is for the absorptive elements that you see around. Sound transmission coefficient is if you want to cut down or isolate noise coming from outside, it is used for that. And mass and decoupling are the two components that are most effective at stopping the transmission of sound from one space to the neighboring space. So I am showing you these images. I'll want to quickly go to the images of actual projects. These are concepts. We always look into internal room acoustics, the isolation class, and noise control. These three factors, the performers have to understand that these three factors have to be looked into before you hire any equipment, sound, or the type of technicians required for that space. Okay. So the HVAC or the air conditioning is something you don't see. It is all built within the space. Sometimes the HVAC, when you are hitting the drums really hard or you're playing the cello, you will see that something is rattling within the space. What is that? Now that rattle is the resonance. Okay, so you start hearing the mic mic stands and things which are touching the drum kit is all starting to make its own music which you never played. So it's very important that you decouple. This is called mass and decoupling. This is a very important factor that most of you musicians might have experienced, and that is where you put a pillow in the bass drum and so many other things to change the sound of that specific instrument. Now, the floor on which you stand, the floor on which the audience is sitting, the audience have the habit of tapping on the floor. Okay. Now, if audience of 300 start tapping, your tempo will go off. So you have to see to it that the audience floor and the performer's floor is decoupled. Okay, that's very important. So I'm showing you one such situation on the screen. Now, sometimes you might have a space which is overlooking the sea, and you paid a huge rent for your concert for that evening to just have a venue which overlooks the sea, giving a very luxurious ambience for the kind of people who are coming in. And you realize, okay, now I have so much reflective element in that space because of the heavy glazing that's around. So keeping the glazing, we can also manage the acoustics of the space by seeing that you have taken the measurements, you have simulated the experience before you start your concert. Okay. So I have already defined how these things are done. This is a situation that I am trying to express over here. And then there are panels. Now different panels will cost depending on the compositions that you use within these panels. Okay. And the rating or the parameters change with the kind of composition you use in the entire frequency band. So key points to remember: when sound strikes a surface, some is absorbed, some is reflected, some is transmitted through the surface. Sound bounces back and forth between hard parallel surfaces. So best way to stop sound transmission through a building structure is to isolate the sound source before the structure has a chance to vibrate. I already indicated about these examples. Now, every construction material has a resonant frequency at which it is virtually an open window to sound, like a tuning fork that sings at a particular resonant frequency. So different materials, different resonant frequencies. Okay. So trapped air is a very good decoupler. Okay. Now I'll explain this much better when we have a technical conversation. An airtight construction is a very key concept. That is the reason why you invest in really good doors. You did everything to the room and you just compromise on the door of the space. That's it. You have changed the entire signature of that space, because you are going to lose out on your low frequencies escaping through that door. Okay. So controlled, reflected and absorbed sound. The quality, it depends on the use of absorbers, diffusers and reflectors. The thicker or denser the acoustic infills you use within the walls or paneling, the better the absorption at low frequencies. So in performance theatre design, the primary objective is to bring as many people as possible within the optimum range to the performance. Yeah. So in the auditorium, no reflective materials around the stage that would distract the audience unless it is intentional. So advantages of balconies bring more people visually closer to the stage. Not so obvious when there are lots of empty seats. That is, example, can close off the top tiers when there are lesser people. So it will be a better atmosphere over there. In terms of seats, audience in balconies will be looking down, not reclining. So balcony edges should be comfortable for leaning on. And ideal scenario would involve adjustable seating heights in the top rows, like movable seats. I'm just showing you an image of an auditorium which was refurbished, a very old auditorium, and air conditioning wasn't there in it. We have put air conditioning later, and we wanted to have the old world charm of this place. So you will see the auditorium that is called the proscenium. There are side wings over there where performers stay behind those wings before your turn comes. Yeah. And then there are monitors on the stage as well. These monitors can be hidden much below the stage, angling towards the performer, so that it does not take up too much of your vision. Yeah? The same stage, when I look from the balcony, this is going to look this way. So now you realize audio is going to make a major difference in this because of the inverse square law. So you definitely have to have fills there. So you will see those fills there on the walls. And the vision has definitely diminished. So you don't want the audio also to diminish. You have to balance their experience. This is what the performer is seeing. Okay, this is the audience that you're going to look from the stage. So you don't want lights hitting onto your eyes. Yeah, so the lights will be much higher, and there are the core team, which is the director or the artist team, which will be there in like a black box at the end of the auditorium. That is where they will control the light, sound, and all those things. It is very important that you don't make too much noise there. So that is the main reason we have a fixed glass for most of these black boxes, so that you can have your internal conversations when the actual performance is going on. So it is like a kitchen, you know. You are sitting in the restaurant, everything looks plush, but in the kitchen it might be a hell's kitchen, you know. People are actually putting things together in a certain pace. The same thing happens in this black box. Now, the auditorium that I showed you, this was the existing reverberation time graph. We had to bring it down to a certain level so that it is ideal for speech and reinforced systems. Before, there were no reinforced systems. So now, very similar scenario, you will see this space which was ideally set for Hindustani or Carnatic classical music. Okay, the Kacheri festival and all those Margari Masam, all that happens in this auditorium. Now it was so heavily damped with too much treatment that a mridangam or a flute or violins wouldn't sound natural. So you are digitally managing it through systems. Now the trustees wanted to have this corrected. So you will see we are doing these measurements over here. These measurements are done. You will see a lot of gypsum with a lot of glasswool core all around the place. So there was a certain timeline. Now all this, how much can you go? The sky is the limit. Okay, how much you want to make it right? Sky is the limit. But when there are limitations like, okay, you have to finish this in 4 months, you can't change the ceiling, you have to do only certain things. So there is a certain direction now. Then you take these measurements in that space, you get the measurements, and then you realize, okay, this is too damped, it is too absorbent, we have to make it more reflective in nature. So what are you going to do? So we are going to refer to certain standards, and then we are trying to go and achieve that graph. Okay, so to achieve that graph, we don't have time, right? So we are going to have simulations done with receivers kept on each seat, and we'll start understanding the order of reflections and the specular echogram and many other things that we do on the technical front. Then we realize, okay, in these limitations we can make these geometric changes in the space, and that's how we arrive at these things that are kept on the walls, and you can call as diffuser, reflector, many other names, but these are all customized for the space for the requirement, and then you put the finishes to it. This is how it would, the process would be. This is how it was before, with the fans and all those elements which was impacting the performance. So after the change, this is how it would look like. This was the demo performance done right after the refurbishment. And then the reinforced sound systems are calibrated for the space accordingly. This is the process that takes place to have a performance appreciated in its right format. Yeah. The same way, here we have the JPT hall. You will see we have taken measurements at multiple locations, okay, from the AA row till the X row. So we looked at sine wave, pink noise and white noise, how it behaves. Okay, so we realized there is resonances in certain areas. We can improve the space even further. So that's where, before a concert that was going to take place, we have reinforced the walls, we have reinforced the air conditioning elements, the ducts, and then the graph completely enhances itself. So these are experiments that have been tried at NCPA thoroughly through the engineering department team, and they're constantly striving for the best that can happen. So this is how the process looks like, and performance spaces, as I said, technology keeps changing. You have to keep upgrading yourself. At the same time, see to it that how can the old world charm be managed. Yeah. So these are spaces adding in diffusion, reflection. This is another space. This is a very interesting space I wanted to show you. You will see the space was designed and defined as a badminton court. Okay. This is on the 9th floor of an institutional building. There are certain very important offices right below this floor. So this is how it looks like. The same place, on the opening of this space, we had Pullela Gopichand opening and playing a exhibition match. In the same space, we have some performances taking place by the institution. In the same space, we have seminars happening. So now you realize we have to prioritize what is the main usage of the space. So first was probably
working under stress,
badminton. Second
time
was to
management.
use this
All
space
these are the required
for
features
other
to
things.
survive
Okay.
in future.
So you will see it is being used as a seminar hall. So you saw it, there was more than 10.7 seconds in that space, which we brought down to 1.69. Again, you will see that for performances this could have been much more lower, but that was just the requirement. Now it is also being used as a classical concert venue for certain artists. The same space being used for something with much higher reinforced audio. So I'm just going to make you hear these. So the same space had 10.71 seconds in 250 hertz, which has now been brought down. So the artists have planned out what kind of content they would play before. So a proper site recce was done. They were educated on what should be played there. Now again, something that was not calibrated and something that was not planned, but it happened there. People are still enjoying it. So it depends what kind of audience is there. So now, for example, so the same space being used for heavy reinforced music, but fair enough. The audience wants to stand up, dance. They are not doing any kind of critical listening there. So this is how you define your space. And by evening, it again becomes a badminton court. So the budget of a project like this is very well defined without too much expenditure. All of it is happening. The client is happy. Performers are happy, then fair enough, you can proceed with it. But when a critical environment is being made, which is something like this, which we had conceptualized, you will see the client or the management wanted people to see how background scoring is done, how performers make content together. And then at the same time, the content being generated here has to be very well mixed, mastered, monitored. So it has to be a reference level space. So this was conceptualized, and then arriving at the brief. Again, time was a major constraint. Everything has come together within a span of 6 months. And this is a simulation that is taking place where, it has to be an orchestral space. That was the main priority. So we have kept the reverberation time requirements as per that. The second requirement that came in is that, okay, if you're building a space like this, let's have some variable acoustics happening here and some previews that will take place, but not very critical previews. So we have planned this space with variable acoustics, and even before it was being built, we have put together these graphs. We have explained everyone that this is what you can best expect in that space. And I'm just going to quickly take you through this. There's a Dolby Atmos HE studio on the top, and the simulation model with finishes, without finishes, with acoustic materials, the overall space, the viewing window where the external public can view inside, but they will not, but none of that noise comes inside. Okay, so these are all multiple layers of parameters that are being followed, and this is the whole place coming together. So for a performer, you would want to have the right, it's not just the performance space, you have to have the pre-function areas also being managed well, okay, so that you're creating buffer areas, you're creating air conditioning that is at different levels as you enter into the performance space. So this is one such interesting space that was done. So you will see this space, which is when it is being used for rehearsals, and dubbing. This is as a preview theatre, but that is not the critical requirement. You will see the drapes coming in and the screen changing itself. The ceiling will change its height. So on the press of a button, the reverberation time signature of that space changes. Okay, even the height of the ceiling can be changed depending on what kind of content you are recording, playing, or performing within. So this is a very critical space designed as per requirement. This is like a full house when it comes to an orchestral recording for a solo recording. At the same time, all these spaces are being used independently without having to hear each other, no structural vibrations or none of those airborne noise entering through and through. And this is where the people outside are also able to see how these things are done. So this was a very interesting space that we had done. There is a lot more information I would like to show you, but I'm reaching the time that I'm given, and I'll just flip through these images so that you get a idea of how these spaces are done and why it is important to technically analyze something before you actually perform in that space. Yeah? And hope you remember those conclusions that I made in the beginning itself, so that if I run out of time, at least I should not miss out on the conclusion. Yeah, this is another interesting space where the balcony or the terrace of an entire institution opens up, and you can close it to make it like a hall as well, so that the noise doesn't go out. So you have multiple such walls that you can do in your spaces. You will see spaces with a lot of brick, so you will have a different acoustic signature in this space. So thank you so much everyone. I have come to the end of my presentation. Apologies if I took you through very fast through the last set of slides, but keeping to our standard timing, we have to conclude here. I would like to answer your questions if you have any. Thank you.
Thank you, Mr. Roy. It was wonderful explanation.
Yeah.
One can begin to understand the complexity of the subject, and that is what is, I think, most important, that the musicians become aware of what are the subtleties, what are the details that they must understand about the surrounding spaces when they sit and start performing, and to best of their advantages. So thank you for introducing us to the subtleties of the performing spaces. Now here are some questions. What are some strategies that can be adopted to enhance sound quality when designing for a performance in a public space, for example, a courtyard or a garden?
Okay. So this is more dependent on, like, you always have a concert shell kind of a setup, for the stage sometimes. And then most of it is managed digitally through the systems. That's how we go about these kind of setups. When it is enclosed spaces, that's where the acoustics and architecture comes into play. Yeah.
So are you trying to say that then in the open spaces there is really not much to control, or can be controlled?
Yes, it can be controlled only if you can kind of control the way how you are seated, the amphitheater seating element.
Yes.
But if you're going to be seated just flat on the floor with all the chairs arranged in one plane, it will not help. Actually.
Yeah, and I think what also the friend is meaning is courtyard or a garden. So it is just very small space in which there is not much to.
Yes, it's a free field situation.
Yes.
Only thing that you can plan out here is, okay, you make them radially seated around you so that that inverse square law doesn't come into play, which I was talking about. Every doubling of distance, 6 decibels is lost. So your sound systems have to be planned accordingly. So you'll need the help of a very good sound engineer to align this setup.
So ideally then would you say, you have a house and there is a courtyard and you would like to entertain your friends.
Yes.
Say maybe 30 to 40 people.
Yes.
And do you think any kind of music can take place, or
Absolutely,
a particular?
absolutely. Yeah, absolutely. Like for example, a very good Indian classical concert can take
But
place
then
in a
you'll have to
courtyard
have
like that.
platform and things like that to make
Yes,
them
yes.
seated.
So, for example, the architecture of that space will define it. Like if it is made of stone, the courtyard, how it is planned out, and you will have to configure the performer's location. So, if you have a wall behind you, it is going to push the sound in front towards the audience. So, as you take, like when I'm speaking like this, and as soon as I add walls around my mouth, it's going to change the way I'm going to sound. So that's exactly how we'll have to place the performer in that courtyard.
So then there will be some strategies that will be
Absolutely, absolutely. It will require on-site recce to set this up
So
for
there
sure.
is no just one formula that can
No, no, no.
fit the bill.
Never, never, never.
Okay, okay. How much of a recording's perceived quality is determined by room acoustics versus microphones and equipment?
So that is now to answer this question. Now, a lot of people are setting up home studios or podcast spaces in their rooms. If you have high traffic areas, if you are setting this up in an apartment and you have a very, a high traffic road right down there, if you have not planned your windows properly, definitely that's going to enter into your microphones. And good quality microphones will take the least amount of detail that is around in that space. So definitely the room plays a major role. And sometimes you have these screens around the microphones, you have to be very close to that. You are setting limitations for yourself. As soon as you treat the room, your limitations of moving around and doing whatever you want is maximized.
What are the key acoustic parameters that performers should understand, even if they are not engineers?
So I have specifically focused only on those parameters. One is the reverberation time, then the speech transmission index, and that's about it. These two things you have to understand, and as I said, that is on the basis of which you will decide if you have to slow down your performance by a certain percentage so that you elongate your pauses, crisp up your consonants, and the staccatos. At the same time, as I said, the audience adding into that space will change the reverberation time of that space as well. So if you put reflective, floors can be covered with carpets and those kind of things. So STI and RT is the main things which the performer can kind of understand and control. The rest of the things will depend on the reinforced systems that are there in place.
So these are the basic two criteria
Yes,
that
yes,
you must
absolutely,
understand.
absolutely.
I have a 10 feet by 14 feet home studio and use studio monitors for mixing. What basic acoustic treatment would you recommend for this room size? And added to this are other two questions. Which acoustic panels, bass traps I believe, and other treatments should I consider, and what is the estimated budget for a basic treatment setup? I think he's going to hire you as a consultant. So be very careful.
Yeah, no problem. The thing is, I started my entire career doing studios of this size, okay? And small room acoustics are more difficult than large room spaces, to be very frank, because you have early reflections. Before direct sound entering, the early reflections hit you faster. So 10 by 14, he or she forgot to mention
Just
the height.
a minute. You are talking about the early reflections because the room is small.
Yes,
so it
absolutely.
starts coming back immediately.
Yes,
And this is
absolutely.
what is clarification.
Yes, and the height is very important, and you can still manage. That is where we make certain customized panels or custom detailed panels with diffusion in it, so that you don't lose all the energy that you're generating out of that space. And what levels are you playing your monitors at? That also makes a huge difference, and the position of the monitors also makes a huge difference.
How can a first floor hall for Indian classical Baitak format, when they sit down squat, be insulated from airplane noise?
This definitely is the facade or the envelope of the building will make a huge difference. So we have been going, so we design, most of these 5-star hotels and buildings, now we specifically get into facade design, because it might be close to an airport terminal. You don't want the entire facade to start rattling. So this is a very technical direction that we have to take to correct it.
How about, what about some software you mentioned can be used to predict the performance?
Yeah, there are multiple softwares which is like Cat Acoustic, Ease, Treble and Odeon. So many softwares are there, but it is again for enclosed spaces where you define the reverberation time, speech intelligibility and set up reinforced systems within that setup. I have already shown that on my screen while I was speaking. Yeah.
How can performers adopt their technique when performing in a highly reverberant space versus a dry acoustic environment?
Yes, I started my entire talk with those 8 points where I was saying that, adapting tempo to the room. If you find yourself in a highly reverberant space, slow down the performance by 5 to 10%. Elongate pauses and crisp up your consonants for singers and actors. And instrumentalists will have to give time for the room to clear, in the sense when you are at a position and you just, the easiest way is to clap. I usually don't encourage clapping in a setup because it keeps changing the whole understanding of the space. But you can first check if there's a flutter echo in your room, okay, and you adjust your stage position accordingly.
But by clapping, you mean?
Yeah, by
To start
clapping,
with
yeah,
clapping.
even snapping or clapping, you can actually understand if there is a direct flutter echo between two parallel spaces. And then you plan yourself, your height, your position within the room, or you might have to add some drapes around you so that at least that flutter will cancel off, And then you have to even go to the audience side and just play something from here and understand what is the audience going to hear. Definitely what the performer hears and the audience hears, both sides, the performer should know both sides, not just from the performer's side of things.
Yeah, I think that is very important
Yeah.
to envisage what is
Yeah.
happening on the other side because they are the main receivers. What would be your ideal beginner to intermediate home studio setup for music production and vocal recording, and what acoustic treatments would you consider absolutely essential?
You should definitely plan, see to it that you have, this is very basic, I can't generalize anything. So if I say the proportions of the room is very important, we actually plan as per the room ratios first. If the room ratios fall within the desired bracket, then
By
having
room
panel.
ratio, you mean size of it.
Size of the room, length into breadth into height. There are Sepmeyer's ratio, Loud's ratio, Dolby ratio. Many ratios are there on the basis of which the room performance can be defined. And if you use certain panels of a certain height, thickness, and of course, Rockwool core is the most cheapest form of absorption that you find. And then you cover it with black glass fabric and then you put wooden slats in front of it so that you create some kind of reflection, diffusion and absorption at the same time. So I can't generalize this answer, but this is the way forward.
Yes, okay. What are some practical ways in which trapped air spaces are implemented in a hall?
Okay, so the buffer zones or the air pockets that are there in the hall, like for example, when you enter the hall, you create a airlock lobby or a sound lock lobby. These trapped areas are very important, especially the low frequency, mid range frequency escaping out of the spaces to contain it within that zone. So that is where I was very specific about the doors that are used for venues. It has to be with proper perimeter seals, drop down seals and rebates so that you contain the energy within that space.
Will variable acoustic treatment help for a venue which is meant as a multi-use facility, and how expensive is it compared to fixed acoustic treatment?
It is at least 4x more than fixed acoustic treatment, and I already showed an example right now that adds on to complications. It is not something that you will find it standardized in the market, it is customized to a space. So everything from design to execution requires very high technical expertise, otherwise it can end up being eyesore later on. Yeah.
How are you using simulation AI or parametric tools now that you couldn't use them 5 years ago? Which are a few useful ones for basic learning for students of architecture?
For students of architecture, I would suggest they should start experimenting with ease trials, but again, or cat acoustic trials. It is there available on the website, and there are some calculators that are available from all over the place. Treble is a very good software, very powerful tool, but it is a bit expensive. Maybe you can start with a trial, and what else? I would suggest something like Insul to understand the composition of panels, to understand how it is going to behave, the STC, the sound transmission coefficient of any composition. Yes, this is how I would go about it.
Which auditoria in Mumbai have really good acoustics? I will answer this. All the auditoria of NCPA.
Yes, I second that whole thought. That's the main reason I feel great pride being associated with the NCPA and its works, because the way it's been planned out, I started my conversation with that, because one hall cannot be a multi-purpose hall, you know. That is where you have 7 venues or 6 venues here.
There's no one size fits all.
Yeah, no one size fits all, exactly. Yes.
So, no, seriously, other than NCPA's thing, I mean, we don't want to name anything, but maybe perhaps you can quote anything. We can go out of Mumbai and you can say in India or elsewhere where you find the best of acoustics.
So all these students that I connect with, I always tell them to come and visit NCPA, because I don't think I've come across something as critically
We appreciate
made.
your loyalty.
No, absolutely, because I've been to very well-known spaces. They might have planned the performance area, but they have not thought about the pre-function zones or the safety or many other things, you know, and it's stuck in time to certain things. And when we try to go in there, we are always trying to add in more flexibility. So that flexibility is available here. That's where I wanted to highlight. Yeah.
Okay, now I want to ask you some question. Do you think that by natural acoustics,
Yes.
you know, when you build the spaces,
Yes.
is it too much of utopian dream to think that you should use the spaces bare without any, you know, amplification or augmented
Yes.
equipments? Is
yes.
it possible at all?
Absolutely. We have done a lot of spaces in that zone. And of course, the size of the space will drastically reduce. You can't have a very huge volume, but you can have a very critical listening environment with very natural materials plant.
But also there is a rider to that, is how I understand now, being working with NCPA and talking to audience.
Yes.
You know, we as human beings are used to now so much of this amplified
Amplification,
sound.
absolutely.
That whatever you do to the
Yes.
hall or theater,
Yes.
you know, you cannot satisfy
So
the audience.
it is like you are fine watching something greenery in natural environment. At the same time, you see the greenery on an OLED screen or a hyper LED. It looks unreal, you know, and it depends what you really appreciate. It's so
Appreciate,
subjective
yes.
now. It's so
Yes.
subjective.
I know, there is no beating of that.
Yes.
So ultimately the appreciator has to be satisfied.
Yes, absolutely,
Right.
absolutely.
Okay, now one more question. You know, we have instruments, the range of instruments.
Yes,
I'm not only talking, and I'm including human voice there.
correct.
With, say, frequency, very high frequency range. You know, very
Yes.
wide frequency range is
Yes.
the right word.
Yes.
Is it possible to then design rooms to be able to
Yes.
accommodate satisfactorily all
Yes.
these ranges? I mean, all these vibrations,
Yes, ma'am.
frequencies.
Absolutely. So, in fact, I had an image on the screen which was specifically designed for hang drums, you know. So, I'm not sure I can put it up here right now. Once the image comes on the screen, I'll just, so this one room, if you can show my screen, yes, This was specifically done for high frequency instruments for hang drums, 400 to 600 hertz.
Where is it and which?
It was for a very dear client in Surat. We
Okay.
made something.
So it's home kind of thing.
Yeah, it is a smaller setup where they can jam, make content. So it can be done. So higher frequencies, the kind of reflections we use within the space, the diffusion, we work a lot on diffusion of spaces. We don't want the energy to die down, because any absorption you use, high frequencies will get sucked out immediately. So you have to work with diffusion.
So that is
more
more intelligent way of controlling.
Yes, absolutely, absolutely.
Yes, very intelligent way.
Yes,
Yeah.
yes. In fact, we have done studios where we have entire wall full of glass, but it doesn't sound too reflective. Not too, ringing is completely eliminated. You
Because
use
of the
glass
diffusion.
because of diffusion and the way how you mount the glass and what composition of glass did you use there. All those things will matter.
What acoustic issue do occupants complain about most that designers never anticipate?
Probably background noise, the ambient noise, and where you thought, okay, just putting panels would have sorted your problem, but then you are dealing with traffic noise and noise from neighbors, all those things. So the doors, windows, openings are very important, and the air conditioning, you are adding more noise into the space if you have not thought about the air conditioning. So that air conditioning is going to bump up your ambient noise by at least 40 decibels without even, so these are things. So that is why when you are recording something, you switch off the air conditioning and then you record. Most of the home studios have been doing that, I am guessing.
For churches and religious complexes, what can be done to improve the choral singing quality where updates have to be minimalistic?
Again, so you have something like a concert shell scenario which we have in the JBT hall. It really pushes the audio content into the
Behind
audience.
the performers.
Yes, behind the performers. That's exactly when I was saying, when you are in a courtyard, if you have a wall around, you keep the performer to that corner rather than keeping them to the length or the center. When you put that performer in the center, you lose the
So
whole
in the specific location, and
yes.
the singers have to come in front of
Yes,
that.
absolutely, absolutely.
So then it becomes like a wall or screen.
Yes, yes, absolutely.
to
So
get
it
the
is
push.
something called the strength or the Q quotient increases. As soon as I go near to a wall, as I demonstrated with these hands, when you're calling somebody far away, you use your hands like this,
Yes,
right?
yes.
So that same concept applies.
So you direct the frequency.
Yes, exactly. You
in a
direct it.
particular way. Yeah.
Absolutely, absolutely.
So now we are at the end of the questions, but if there is anything that
Yes.
you would have said it before, I mean, meant so that you didn't have much time. So
No
perhaps
problem.
if you want to
Yes.
say anything, we can spend 5 minutes.
So I am. I think I touched upon almost everything. I didn't expect that I would touch, but yes, I didn't talk in detail about certain projects by where I was just scrolling down images in the end. If anybody has any questions, please feel free to connect, and I will be able to answer them.
Okay, so here is my very naive question. Here at NCPA we have multi-purpose, occasions.
Yeah.
We have where we are standing today, the experimental theater. We have, this evening also we'll have a kind of a guided listening session. We always have a concert for 300 people. We have play, we have certain times documentary screening. So we are trying to use it, for the multi-purpose. But that's not ideal, am I right? Unless you have, some kind of controlled
Yes.
equipments used,
Correct.
you cannot use the given space for different purposes like what I mentioned just now.
So, ma'am, as I said,
And one more item I will add.
Yes.
Supposing we have, in music itself, we have Indian music, which is a sit down and,
Correct.
not so many
Exactly.
range of frequency where versus say Western music where there's instruments of
Yes.
so much wide range of
wide range.
frequencies.
Yeah. So let me put it as a question to you again. Imagine you have Jagjit Singh, the late Jagjit Singh, doing his performance. Just look at him sitting on the stage with the kind of instruments around. how would you envision the audience to be? I'm just asking this question like, what kind of audience? I'm not asking you to be judgmental about the age or the type of
No.
people, but I'm just saying, are they standing like in a normal concert?
No, they are sitting always.
They're sitting, yes.
The Indian audience is always sitting.
Sitting,
Unless it is a band music and
Yes,
people
yes.
are standing and clapping and all that. But
Exactly.
we are not kind of taking it under the label of Indian.
Yes,
You know,
yes.
Indian music per se, the
Correct.
artists are also sitting and the audience is
Audience
also.
also sitting.
You
Yes.
know?
Yes.
Yes.
So you would like to have the audience seated and not making too much noise also.
Yes, yes,
So it
absolutely.
depends heavily on the kind of audience. It is a tit for tat kind of a scenario where if as a performer, if my content is so serious, the audience is going to be serious. So it is very psychological that way. And sometimes I'll make it more easier for you. Imagine you are an instrumentalist. You play your violin every night between 8 p.m. to 10 p.m. That's where you really feel inspired to play. And your neighbor knows you are a violinist. Okay. You dampened your room completely. Even the slightest frequency will make the neighbor, I mean, if the neighbor doesn't like violin, he or she will be like, no, you are disturbing me. That's how the whole psychology of sound is. So unless and until you change your space or you take another place and you have left that neighbor, that will always exist. That conflict will always exist. These are things which I have experienced over the years. And when you said definitely the stage and the audience space both have to be effectively managed so that it is respected. Yeah.
Okay, thank you so much.
Thank you, ma'am.
Okay.